Well, hello again, YouTube. It's Petey, and I am here to talk about my latest do-it-yourself magnetic stir plate. So this particular unit was made from this carry case that I got from Goodwill, and the guts of it is an Arctic Air. Now, an Arctic Air is a swamp cooler. It's a little white plastic cube that they sell for $40 on infomercials on the internet. They're a swamp cooler. It's a little air conditioning unit that you put cold water or ice cubes in it, and there is some diffusion filters and a PC fan, and it passes air through these diffusion filters, which you load it up with cold water, and it will lower the temperature of a very small area. So it actually does make it more humid, but I guess in homes in the areas like the deep south where it's so unbelievably hot, it's so expensive to run the air conditioners that people actually will try these things. I mean, my understanding of an Arctic Air is that it's a novelty product. It's something you see the infomercial for, and you think, oh, one of these little cubes, it's going to cool down. I'm not going to have to run my air conditioner. Well, I made a swamp cooler. I was living in my car. I was 17. We had just lost my father, and my mom threw me out of the house for playing bass and playing the devil's music. And I was living in my car, and I made a swamp cooler, and then later on, I would quickly realize that was not really non-efficient or completely inefficient, not a good idea. And later on, I found a Illinois Bell fiber optic node, an underground facility that had 6 window unit air conditioners built around the base, and there was one output exchange unit, a little vent that put out ice cold air. And I used Glad bags. I took a razor blade and cut the last inch off of about a half dozen Glad bags, and then taped those together with 3.5-inch masking tape very neatly and carefully, and made a tube where when I connected that to this unit, rudimentarily, I had a baffle made from cardboard, and I would attach my baffle to the output of this unit, and these bags would kind of inflate and carry themselves to the window of a Chevy Citation where I was inside sleeping, and it worked really well. That system worked fantastically. You had to bundle up or you would get cold, and that was something that was priceless for me, as it was really uncomfortable. It was bad enough that, like, my dad died, my mom went nuts, kicked me out of the house. I'm sleeping in a car, and it's a record-breaking heat that year. So my experience with the swamp cooler is, and when they came out with those products, of course, I did a review of it, and I slagged the product and said you would have to be, out of your mind to think that just pouring water into this device is going to do a job of something like an air conditioner, which chews through the amperage and wattage and current in order to do its job. Now, recently, I found myself considering of trying to build another magnetic stir plate, because I have another one here. And we went out looking at the resale stores to find fan units, or maybe a dimmer switch that was made to reduce the current flow for a ceiling fan. I thought maybe I could try that as a rheostat to slow it down. And I came across a Arctic Air unit. So I gutted that. We also found this little case, and I gutted the Arctic Air unit. It had the fan, and then there was a control board, which I found the control board, not only did it change the color of the LEDs, which is completely useless. They turn it on blue if you're really hot. It had another button that would adjust the speed. So there's 3 speed modes on the circuit, and when you turn it on, you'll hear it come on, and then it kind of here, let me do this again. It kind of builds its way up, and then once it's stable, it'll wait for a couple of seconds, 3 seconds, and then it'll get even faster. You hear it kick up? So this is full speed. Now I cut in a controller to adjust the, but you could slow it down considerably. You could get it really slow. Now mind you, this is running without the additional weight of the rare earth magnets that are required for the full build. I've got those coming. I didn't want to, I had ordered these 3 millimeter thick, I think they're 20 by 10 bar magnets. So that will be what I super glue onto here, but basically for the build, I have a LM2596 circuit, which these cost about $1 or $2. I think they were $1.50 when I first started buying them. Now, since the war in the Ukraine, depending on shipping, everything's kind of gone crazy. But this is a voltage, it's a buck or a step down transformer. It kind of works different ways. And that has, when it arrives, it will have a 10K trimmer potentiometer. Now I removed that 10K trimmer potentiometer and I cut in my own 10K B potentiometer here. So I unsoldered that and removed it. It's got 3 pins, and then I soldered a 3 wire onto that and ran that down to this pot. And that's what gives you the additional adjustment besides just the 3 stages, which is available through the printed circuit board that comes with the Arctic Air. So I'm using the main PCB from the Arctic Air to get those 3 different speeds. The device runs on a 5-volt, 2.5 amp power supply, which is one that came from a, it's not the proper power supply from the Arctic Air. I got the Arctic Air at the resale store for, it was $2.99, but I think it was a 50% off tag. And what I'm getting at is the Arctic Airs are just starting to show up at resale stores, and they will continue to do so for about 2 or 3 years. In about 6 months or a year, it'll probably peak with people that bought them and then realized that it didn't really work very well, and then or maybe they got it as a gift and then they would take it into the resale store. So if you're interested in magnetic stir plates, do-it-yourself magnetic stir plates, this is a really good way to go, getting one of these, because it comes with the fan, a larger diameter fan. It's a 1 ton or 120 millimeter, and then it has that circuit board, which you could very well move the LEDs around and put the LEDs up higher, and then throw some light up on your subject. And, like I said, it's good to have flexibility and have all the speed adjustment. I have these 3 speeds that come due to the PCB for the unit, but then I also have this fine-tuning adjuster, which is an LM2596. It's a voltage regulator it's a buck transformer. And they're blue boards. You can find these on eBay. They're just a couple of bucks. Like I said, there's an input and an output, and then there's an onboard potentiometer. That's a trimmer that you adjust with a screwdriver. Well, I removed that, I unsoldered that, and then just soldered in my own 10K potentiometer, and that worked very well. Now, I have these the colorful LEDs on the front panel, which demonstrate the modes, the modality that it's got. When you turn it on, it's in high mode, and then you can do medium or low. These LEDs are they are SMT, which is really small. They're about 1.5 millimeters wide or length. They're tiny LEDs that are mounted on the circuit board. So the smart way to do this would be, like in this case, I have a clear device, a clear top panel. And why did I even cut this out? I should have just left it on there, right? Just left it solid. Why do I need a hole? The magnetism is going to go through either way. It's kind of dumb. Live and learn. And like I was mentioning, the easy way to do this would be to attach your printed circuit board so you can just see the onboard LEDs. Well, I didn't want to do that. I wanted individual different colored LEDs, 5 millimeter. I was originally going to go with 10 millimeter, really have it up like almost like a stoplight. You know, they're 10 millimeter. They're pretty big. So what I used was single solid core, single strand, like less than 1 millimeter, this really thin wire, and we used my drill to braid the wire. If you look inside, it almost looks like a festive candy cane. It's red and white, this wire, and it's solid core wire. And the reason that I used that was because it's so fine, and you have to attach to very tiny points on the circuit board. So we took about 3 feet of this wire, a red piece and a white piece, and we mated them together roughly, and then bent over about 1 inch of it, stuck it in my drill chucked the drill tight, and then my wife held them apart, and I would slowly spin, and it braided the wire. So we made our own braided, real thin diameter wire, and that's what I would recommend when you're attaching a wire to a circuit board where it's not going through a hole, and it's a real fine diameter soldering pad. So I took it's a 60-watt iron. It's a pretty large, not a very pointy tip. It's kind of rounded. And I applied flux, then I applied solder, and melted both sides of the pad for the LED, and then it would just stick to the iron, and I could remove it. I pulled those off. I applied more flux.
Do you need one?
Yes, I do. And at that point, I had removed the LEDs before I was interrupted. I had removed the LED, and then I had put more flux on and added more solder, because I mean, this is tiny. This is a head of a pin is larger than what I'm talking about. This is like the point of a pin. So we have 2 little bumps of solder on the board, and then I have this wire. Lay that in, make sure you get the polarity right, and tack it on there. And when I say tack it on there, it required multiple applications and redoing it till I got to the point where I could wiggle the wire and it didn't break free. Because there was working with this single strand solid core wire, the solder doesn't really want to stick to it, and the solder points on the board are tiny. It's just a bad design. So like I said, that's a little bit hairy. And if it's your first time soldering or you're not really experienced, I would recommend don't try to cut in external LEDs. Just mount the circuit board where you can see it. Or if you're using, let's say you're using a cigar box, you could just the same drill some holes out of it and mount the PCB underneath there where those holes are. And then what you would do is tape off with masking tape on the front, open it up, flip it over, and pour hot glue in there. And then go ahead and screw the PCB in, and you would have these 3 lenses where you had drilled holes and applied the hot glue for you to be able to see through. That would make much more sense than going to all the work to run 3 separate lines for these color LEDs just to show off that you can. So the circuit is the 2.1 mil inner diameter, 5.5 mil outer diameter DC plug jack. Like I said, it's a 5 volt, 2.5 amp power supply. The stock power supply is 5 volt. It says on the unit, 5 volt, 1.5 amp to 2 amp. I guess they weren't sure. Anywhere in there is good. And anything above that would be fine. They just want you to have a lot of amperage. And I did try running this unit, the circuit board and the driver board and the fan through a lower amperage, 150 milliamp / 300 milliamp multiple voltage power supply, like a Kobe or a little Radio Shack multi-adapter where you can go from 3 all the way up to 12. In reality, it's more like 6 up to 16. And that device did power the unit once I got it up over 6 volts, despite the lower amperage. When you hit it, slam it with extra voltage, well, the LEDs light up really bright, which tells me one thing: you're shortening the lifespan of the LEDs by running it off the improper voltage. So you really want to run it closer to 5. Now, I found that the stock, without adding, like, you could build this and don't include this voltage regulator board. Okay, there's 2 circuit boards on this design here. Design, here I said that. It's just a bunch of crap that so this one here is what you get out of the white one. The tan one is the one that you get that comes with the fan in the Arctic Air. This is the fan controller speed. This gives you the 3. There's a button on board. On the board, there's 2 little button spots where you solder onto those buttons. Right on there. Right where the solder is on the PCB, you solder on there. And I had cut holes to let that stuff hang down through here. You can see those switches are there. There's 2 switches. One of them changes the colors of the onboard LED, and that stopped working halfway through the project. So I don't know what I did, but I blew that up. And like I said, I was trying to run it on lower amperage, and then I went higher with it. I went all the way up to like 12 volts with this multi-adapter, so I'm sure that's how I burnt that out. Maybe I just burnt those LEDs out. I bet you that's what's going on, because they were quite a bit brighter. If I replaced those LEDs, they would work. Now, when I was giving it, let's say, 5 or 6 volts with a lot less amperage, because it calls for 1.5 amps, I was giving it 300. It would come on, and it would blink. The LEDs would blink. It would spin a little bit, and then it would stop. Like, hey, you don't have enough power to do this. So keep in mind, if you run into that, you need a better power supply, something with a little bit more current or amperage. Now, there is 2 output ports on the PCB, the stock PCB. One of them is being used, the other is not. You can see that this secondary one, the second one right there, nothing is connected. Now, on the design of the Arctic Air, it goes to a piezo sensor, which when you fill it up with water, the weight from the water will activate that and close the circuit. So I found that it didn't want to operate unless I shorted that. So rather than plug the thing in and just short 2 wires and have it sticking up, I just shorted that on the PCB. And you will need to do that. But you, like I said, you don't need to add the LM2956. But if you want to have an extra flexible unit, you put that on the input. So the power comes in. Actually, scratch that. The power comes in, it goes to the stock PCB. It comes out, and instead of going to the fan, that's where we cut that line and run this voltage regulator. It's called a step down, step up voltage buck transformer to LM2596. I removed the stock 10K set and forget trimmer potentiometer and soldered in a 10K pot. Now you would think that pin 1 would go to pin 1, and then pin 2 would go to pin 2, and pin 3 would go to pin 3, and when you turned it up it would go high speed, and when you turn it down it would go low. No, I had to invert those. So when you're hooking this up, flip-flop your pot and then it'll run right. You won't have to redo that connection. Other than that, that's how it goes. This is the making a magnetic stir plate out of the swamp cooler design, the Arctic Air. 3 speeds, and then with the voltage regulator we get the additional. And you can see this stock LED is working. It just won't change colors. You used to be able to change colors with that. So you can get it really slow. And mind you, there's no magnet attached and there's no volume. When you actually have like a 4-liter jug on there full of molasses, you know, you're going to be able to throw a lot more power in it and it's going to run a lot slower. And that, to me, it's always a balancing act between the strength of your magnet and your magnetic stir bar. Because when you get too high RPM, bing, ping, 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 ricochet rabbit, it'll come uncentered and bounce off the inside of your glass, is my experience of making these homemade ones. So this one has the advantage of it's got a plastic top, because plastic or glass is good if you're working with moisture. A lot of guys will build these with cigar boxes, and I did too, and then the circle that I had cut out, it lifted up around the sides from the moisture. And I didn't like that because it made, like if I put a 2000 ml volumetric flask on it, it makes it unstable. Anyway, you guys, if you have any questions or things to add about this input, I'm not some brilliant guy. I'm a goof. I'm a hack. I do things the wrong way. Again, I have no idea what I'm doing. I did it wrong. I'm sure you could do much better than me, and I'm sorry. So you have a great day, and I'm so sorry I let everyone down. Peace.